So we're still working with scatter plots today, and we're still working with trend lines. Oh, by the way, lines of best fit. But today we're going to come up with the equation. Oh yes, y equals mx plus b is coming back to write the equation of the trend lines and then use those equations instead of the physical graph to make predictions in the future. So before we start, let's just make sure we've got all of our, slope and how to make those lines and what's B and all that. We're just going to do a couple problems here. So I would like you to remember how to find the slope between 2 points. The good news is, notice they're all positive because with scatter plots, real world graphs, for the most part, we're going to see all positive data. So we're going to just step through these and make sure you know how to find slope again. So let's take a look at number one. You're going to get your eyes on the y's and take y2 minus y1, so 180 minus 10. You got to start with the 10 for the x, and 10 minus 5 would be 5, and 80 divided by 5 is 16. So is that a good reminder of slope? Now, try it. If you've messed up the first one, you got 2 more chances here to make sure you get back on track calculating slope. So 10 minus 4 is 6, and 7 minus 2 is 5. Now this time 6 divided by 5, because it's a real world graph, we're going to make it a unit rate. So 6 divided by 5, it's about 1.2. One more. And did you notice this time I did the 50 minus 270 gave me a negative, and the 6 minus 1.5 gives me a positive, and negative 220 divided by 4.5 is negative 48.9. So here's a negative slope. Just want to remind you again that whatever whatever y you pick, you must pick his coordinating x to start your subtraction, your change in x on the bottom. So that is how we calculate slope. There's a reminder. Now let's take a look at 3 graphs. And what I want you to do is find the slope off the graph and find the B, the y-intercept. Let's just start with number 1 and see how your memory is doing on that today. So first of all, you kind of have 2 ways to do it. I would use the rise and the run, and you need to use like this point and this point because they're in the crosshairs. And notice it's a positive slope, and notice that each block is going up by 50, 50, 100, 150, 200. So as I climb from this level up to this point, I would have to go 50, 100, 150. Now as I go to the right, I'm going from 5 to 15. 5 to 15 would be 10. So I have 150 for my rise and 10 for my run. 150 divided by 10 is $15 per person. Dollars per person. Remember, real world slope is basically its rate of change, and it's a unit rate. So we wouldn't leave 150 over 10. We'd divide it, top divided by the bottom, and we put our units in. Y unit over X unit. Okay, what's your y-intercept? Well, the line seems to hit, right about there, which I'm saying is about midway. So if this block is 50 and that's half, it's about $25. Now, if you put 26 or 27, that would still, that's right. It's an estimate. You wouldn't put, 90. You wouldn't put 2. Like it's somewhere close to the middle, which would be like about $25. We could now go on and write our y equals mx plus b, and we'll talk about that in a second. Can you come over and find the slope and the y-intercept of this one? So did you get the slope to be 2 inches per minute? So if I'm going from here and I want to go to the crosshairs because I don't know where this one is. So see this guy in the crosshairs and this one? I'm going up to 4. So my rise is 4 and my run is 2. I'm doing 4 inches in 2 minutes. 4 divided by 2 would be a unit rate of 2 inches per minute. And what is the y-intercept? We start at 0 inches. I'm just going to remind you of a phrase here, which is proportional. So if you take a look here, this is linear, this line, but it doesn't hit the origin. So this one would not be proportional. if you took each y and divided by x, 100 divided by 5 and 250 divided by 15, you will not get that same number. Over here, it's a line going through the origin. It is proportional. So every point on the line, when you take its y divided by its x, you will get the same number. So if you take 4 divided by 2, you get 2. If you take 8 divided by 4, you get 2, and that'll hold all the way up the line. With a proportional line, the ratio of y to x for every single point will be the same number when it's proportional, but when it's not proportional, the ratio of y divided by x will not be the same. So if you had a table and didn't have the graph, that's how we did it. Okay, last one, slope and the y-intercept. So this time, I hope you caught the fact that the slope was negative. And again, each block is 50, so we're going down 100 for 2 hours, down 50, down 100, divided by 2, you're dropping 50 miles per hour. What's your B? Started at 350, in this case, miles. So now let's just go on and remember how to create an equation of a line. So when we're going to create our slope intercept, our y equals m slope b plus b intercept, y equals mx plus b, you just are going to write the equation, but we always define our variables. So the first thing we're going to do is really easy off of a graph. The x in our equation is going to be the number of people, and the total cost will be our y. So we write that defining our variables. So anybody who's looking at our data can tell without having to go searching for it. And now we're going to write y equals, now these are the problems we just did a second ago. So we're going to write y equals mx plus b, and we're going to put the two pieces together. So if you go back, you're going to remember here that the slope was 15 and the b was 25. We started at $25 and every person adds 15. So we started at $25 and every person is going to add 15. Now, I'm not going to have the video stop because you can't see the other slide, but I just want you to remember that, again, defining variables, x is your time in minutes, and this is going to be the water level. Looks like you're filling something up. You're going to put y equals, we found the slope to be 2x. We started at 0, and remember, plus 0, we actually don't have to write it. So there would be the equation for this line. Finally, this one is going to start at 350, remember, and it's going to drop. So we're going to have a negative. X is the number of hours, miles the distance. So, maybe we have 350 miles to go to get home. And then our rate of change, our slope, was to drop 50 miles for every hour. And we started with the 350. So once you have these equations, you can make a prediction and talk about, in 3 hours, what will happen? Or you could talk about, like, when will I be home by putting 0 in for y. And we did that in our Unit 4 a lot. And we'll continue to do it, okay? So today, we're going to take those ideas that we already have, and we're going to take the last video of our trend lines and try to make predictions, but not use the graph. Instead of, we're going to use our function rule, our equation, y equals mx plus b. So if you take a look at this scatter plot, we can see that it's grade versus study hours. See, I don't even need a narrative. I can just look at the graph. I can see this is my percent grade, and 85, and 90, 100, and this is the hours studying. So if we were to interpret this scatter plot, we can see that it has a positive correlation. So the more hours I study, the better my grade, right? So positive correlation. It is linear. There are no outliers. There are no clusters, right? Remember that from last video. We draw our trend line through the center, and now we're going to learn how to write the equation of that trend line. So the first thing you need are 2 points on the line. And so it does not have to be data points. So you basically ride up your line until your line hits the crosshairs or is really close. So you see that right here, my red line is hitting 4 hours of studying, 70%. So you see I put a little purple ring in there. And then I go up and I need another one. No, 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 no. We always need 2 points for slope. No, 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 no. And right here at the point 10 hours of studying, 90%, I put another ring. Those are the 2 points I'm going to use to calculate my slope. So again, defining the variables. X is going to be our hours studying, and Y is going to be our percent grade. So when I go to list this point, I'm going to put X of 4 and a Y of 70 and an X of 10 and a Y of 90. So here's defining our variables. We've been doing that forever. And here is our points that I just mentioned. So now I'm going to calculate slope like we reviewed. I'm going to get my I's on the Y's, and I'm going to calculate the slope. 90 minus 70 over 10 minus 4, rise over run, and I end up with 20 as my rise, 6 for my run. It is a real world graph, so I'm going to pick up my calculator. I'm going to take 20 divided by 6, and it's about 3.3. Now I'm going to look for my B off the graph, and where does the line seem to hit? Now this is a bit of an estimate. See the word estimate. So it's close to what value? And in this case, it is close to, it looks like a 57. Now you wouldn't put 61 and you wouldn't put, 40 and you wouldn't put 51, but somewhere close to that 57. Did you put 58, 57, 56, right? That's all kind of close. And then we're going to write our equation, y equals mx plus b. And there is the equation of that trend line. About. Please remember when we drew the trend line that the line doesn't have to hit data points. And when you pick these 2 points to write the equation, they do not need to be data points. They need to be points on your trend line that are closest to the crosshairs, so you can name them with their coordinates. So now, why do we care? So now you can use that equation, and you could go past the data, you could go in the middle of the data, but you can make a prediction and not have to look at the graph. So if I wanted to know, what if you're going to study 8 hours for this particular exam in college or something like that? What could you expect for a grade based on your trend of how you did in the past, which would have been the original data points? So you're going to take out your X because X represents the hours. You're going to put 8 in and you pick up your calculator. And when you do that math and simplify it, you would get about an 83.4%. And let's just show you, we can see this on the graph. And if you go here and kind of go up, you can kind of see the point that I'm touching there is about an 83.4. So you expect to earn an 83-ish% if you study 8 hours based on your past trend of what you did as you study for other exams. So now I'm going to let you kind of walk through this one with me. So this is animal longevity. That means years. How long does an animal live? That's your longevity. And this right here would be your maximum, the oldest a particular animal ever lived, and this would be the average. And each one of the points up there is a particular animal. We don't know who is who, right? So this point right here, this animal, his average lifespan is, let's call it 8 years. And the oldest one that ever lived of whatever that was 20 years. Up here, when we get to these really old, these could be those, big tortoise that live, right? It's probably even something, one of the tortoise, but notice the oldest one that ever lived was, like 78 years. And they usually live to be about 40. So we don't know once we plot the scatter plot who each point is, and we kind of don't care. We're just trying to see, are these two things connected? That's what we're trying to see. And if I look at the scatter plot, there's a correlation. There's a connection. So I draw my trend line, and then I go up looking for points in the crosshairs. And this picture already put, like, that wasn't necessarily a data point. They put the point in, I'm ringing it. And then you go, no, 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 no. Boom, there's another one. So those are going to be my 2 points. My X is the average years. My Y is the maximum. So that's what it means to define variables. And anytime you write an equation in math that's a real world equation, you got to let everybody know who X and who, what do the variables stand for. We pick the 2 points, and notice it'll be 15, 40, and this one is 35, 70. So there's my 2 points. I now stop looking at the graph for a minute, and I calculate slope. Could you please calculate the slope of those 2 points? Now, we should all agree on this 100%, but 70 minus 40 would be your the top, your rise, and 35 minus 15 would be the bottom. 30 divided by 20 to get a unit rate, and it's 1.5 maximum years per every year average, basically, okay? Now, this is pretty easy, except notice it's not hitting in the crosshairs. It's right about there. So, what would be a good prediction? You see me putting the X for that B. I said 18. I think 19 or 18 would be a good pick. You wouldn't put 11, you wouldn't put 22, right? But somewhere close to that 18. This is an estimate. So, it's going to be close. And if it's not the right answer, but it is a right answer, but you can go off by picking the wrong number. And then you write y equals mx plus b. And now you could say, well, what if an animal lived an average of 50 years? And if you put the 50 in, multiply it by 1.5, add it to 18, that would give you an idea of what the maximum longevity would be of that animal. So you can use your equation like we did a minute ago with the studying. This is covered in your book on page 79, and you're going to see some yucks here because they don't put the title. We know that. So this was cellular would be phone subscribers, having cell phones. And this is, Mr. Yuck, years since 1999. So this right here is 1999, and this would actually be 2000. It's a year after 1999. I don't know why they don't just say since 2000. Again, did they start their study in 1999? But it's a hard scale, and you got to pay attention. So you plot and you make your scatter plot, you draw your trend line, and then you ride up your trend line, and notice that point right there would be 3,150, and I do, and that one right there would be 9,275. Notice they are not blue points. They're not data points, but they are on my line, and they are in the crosshairs. Then I would calculate the slope, and they work it out to be 20.83. They're holding out 2 units. They're rounding to the 100th. And then the y-intercept, you're going to follow that line and kind of hit and say, okay, it's right about there. And this block is 25. They're putting 87.5. You're not going to put 76 or anything below 75. You're not going to put anything above 100, but somewhere in that 80-ish kind of place, 88, 89, 90, a little bit less, that's kind of where you would be. And they write their y equals mx plus b equation. And now you could put in, a certain year, which they do. They say, what about 2015? I just got to remember that 2015 is 16 years after 1999. So you put 16 in, you do all the math, and for them, this particular, study shows that there would be over 420.2 million subscribers. So I'd like you to give it a go here. So on page 680, there is this scatter plot. It's the Got It, and it shows the graduation rate of high school students, and since 1998. Oh no, we're not going to do 99. Now we're going to do 98. So just realize that this would be 1998. 1 year later would be 1999. Here's 2000. 2001, 2002, 2003. So Mr. Yuck is down here to remind you to be careful when you make this prediction, okay? And don't forget your title. So the first thing you're going to do is define your variables. You're going to pick 2 points and find the slope. You're going to estimate your initial, value. You're going to see where, what is the y-intercept. You're going to write your y equals mx plus b equation. And then finally, we're going to answer the questions to D using that equation. So let's see how you do. Stop the videos. Well, the video is going to stop, and you're going to walk through those pieces. So defining the variables is pretty easy. You just take them off the graph. X is going to be your year since 1998. Boo. Y is going to be your graduation percent. Now you're going to pick 2 points, and as you go up, I picked the 160, and then no. And right here, 465. And, you could have used 770. And really, there's not much else happening, right? Those are sort of the points So this one, and I would understand if you picked the 770. Now, once you pick those points to find the slope, you're going to do y2 minus y1 over x2 minus x1, and your slope should have been about 1.7% per year. You're going to estimate the initial value. So the initial value is like right where I'm pointing my cursor right now. It's not going to be 61. It's not going to be 55 or 56. It's right below 60, and I called it about 59%. And then you write your equation. Y equals mx plus b. So the question says, use the equation to make a conjecture about the graduate in 2020. So the first point is, remember Mr. Yuck, you're not putting a 20 in here because 2020 is not 20 years after 1998. It's 20 years after 2000, and you have to add 2 years. So you should be using 22. Then you put 22 into your equation. And how many, or what would the percent graduation be if this trend continues in 2020? So 22 times 1.7, it equals, add 59, and it's going to be about 96.4% if this trend continues. So today we took our scatter plots and our trend lines a step further. We did everything we did in the last video, but now we look on our trend line for 2 points in the crosshairs on our line. They do not have to be data points. We write those points down, making sure that we let everybody know what X and Y is, which is really easy off the graph. That's called defining your variables. And then you're going to get your eyes on the Y's, Y minus Y over X minus X. You're going to make that a unit rate, old news, right? 5 divided by 3, and it's about 1.7% year here, right? You're going to estimate the B. Where does the line look to hit the y-axis? And that is an estimate. You're going to write your y equals mx plus b, and then use that to make predictions in the future. And you're going to notice that x of 22 isn't on the graph. There was no way of using our graph to determine, what would happen in 2020. And that's how they make predictions about all the things we hear, how much, money your house will be valued if a certain trend continues. The virus, what's going on with that in X number of years, what's going on with climate change, all these things that they make predictions and talk about in the future is based on the idea of what kind of model does the data fit. And if it's linear, you learn the exact same thing the scientists would do to make those predictions. I hope you have a great day. We'll be doing more of this the next time I see you. Take care.